is and oxidation. These are not these are not dangerous reactions. I mean, let me just put for you, since you may want to see, you may want to see something about it. For esterification, we just know that you'll be having your alcohol. We don't care what it looks like, whether it is in the something like this, and then we have an OH. Then we react with something like, where here there's a double bond O, and then there's an OH here. What we just know is that the carboxylic acid will give an H, then this will give the OH, then they'll come and join, so they'll just come, and you can put your acid here to say H plus, okay? And then what's going to happen, you can put the HCl and heat. That's the best thing. Then what is going to happen is you're just going to have whatever you start with, okay? We're not concerned about that. You can start with your carboxylic acid if you want. So remember to do it exactly like it was. So we have the mountain, I'm just doing it like that. Then we have our double bond O, and then we have the O. Then basically what then happens is this guy comes and joins. So how many carbons did he have? 1, 2, and 3. So we'll have 3 more carbons there. So it's going to be 1 here, 2 there, and then 3. So it's now exactly like it is. And if you want to put the name, remember, for the name, you start with this part which is not connected to the double bond. There are 3 carbons there, so it was propyl. Okay, we say prop for propyl, then we say propyl. Then how many do we have here? 1, 2, 3, 4, 5. 5, so it'll be propyl pentanoates, okay? And that's the name. That's easy. Esterification is easy. Then we have oxidation. Okay, for oxidation here, we are dealing with reactions of alcohols. Okay, so we have oxidation here. Now we say we know for primary alcohol we can oxidize it. For it's like we have something like this, yeah? Here you have your primary alcohol like this, you know what I mean? This is your primary alcohol, where you have an alcohol connected. The carbon with the OH is connected to one other carbon. That's why we say one other. So this is your primary alcohol. Now, if you oxidize this, one, here we talk about oxidation using KMnO4, which goes straight to carboxylic acid if it's a primary alcohol. We know we have other oxidizing agents. We can use PCC. We can use the Swin oxidation, where you have those 4 things. That is another thing, taking us to aldehydes and ketones. You can go and check on aldehydes and ketones. It helps you to see that. But for primary alcohols, they can go all the way until you get to carboxylic acids. And we know what just happens if we keep going with this KMnO4. KMnO4 takes us to carboxylic acids. What just happens, we know that this OH becomes a double bond O, okay? That becomes a double bond O. So OH becomes a double bond O. Whilst for it to do that again, an H must go, okay? An H must go. Then the H that remains now becomes an OH, like this. Then that's just what happens, okay? Then the rest, nothing changes on the rest, okay? So this H becomes an OH, this H goes, and then this becomes a double bond O. So that's just what happens. And that's, you'll be having your carboxylic acid. Because the primary alcohol, why? The OH is right at the end. You can see that the carbon connected to the OH is only connected to one other carbon, okay? The OH is at the end. Okay, that is what happens. Now for oxidation, you can have again a secondary alcohol, which is some alcohol which is sitting inside, where you have your OH like this, then goes to a carbon, blah, 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 blah. Now what happens in the situation like this? What happens, and we know that they don't normally give you in this form. They normally give you like this. Just do this. And then here we have our double bond O. We have an OH rather, sorry. Right? So now what am I going to do? How are we going to do? What happens if you mix it with KMnO4, if you oxidize it with your KMnO4? Well, if you do with KMnO4 here, it just goes to a ketone because this is a secondary alcohol. The carbon is connected to 2 other carbons, 1 and 2. Okay, this carbon with an OH is connected to 2 others. So it's called a secondary alcohol, which is 2,0 to say just 2 other carbons. So here we have it. What would I do it? It'll be like a ketone. How do I get a ketone? Well, this OH just becomes a double bond O like this, okay? And then 1H, which was here, will just disappear. And now you have your double bond O. That's what happens, and you have your oxidation. This is really not important. These are not the reactions of alcohols that we really need to know. With the dangerous ones, the dangerous things on alcohols that you've seen so far, the things that you must make sure that you remember. We saw, okay, halogenation, we know with HBr, we know with S-thionyl chloride, and then we know with these guys as well. So we talked about it, okay? And now all we want to do is we want to see, what else did we do? This was, halogenation was the crazy one. It's really the one which took us a bit of time. to see which one works, and whatever does, you can go and check. And then we saw esterification and oxidation. It's not important. Then the other reactions now are reactions of alcohols with metals. So this one doesn't even matter. Like if you have an alcohol like this, whatever, if it's a primary or secondary, we don't care. Alcohols react with metals, and when they react with metals, what you should know about this section which we are doing right now is if you add a metal or a metal hydroxide to an alcohol, we are now adding to an alcohol. Remember that we made an alcohol by adding NaOH to a halogen but now we are making we are adding these two alcohols. So what happens? So we can have an alcohol, we can add a metal, we can have an alcohol again, and to that alcohol we can add a metal hydride, like to say NaH, like this. Okay, like we can have something like this, right? Here we like to put 2 just so that we get hydrogen, but when we have a metal hydride we don't need to put 2. This would lead us to what just happens is the H goes. When we add these guys, something with a metal, the H just goes. So in here we would have 2 of the same thing, but it's now O minus and K plus. Okay, then this H, remember there are 2 of them. Then what happens is this H now goes, and since it's 2, it becomes just H2, hydrogen. Now when it's like this, we don't need to put 2. What happens is if we add this to an alcohol again, the H goes and it joins this guy. Then the Na comes, okay? So this becomes O minus Na plus. And here we'll end up having we say plus, this becomes H2. And this is called potassium alkoxide. This is called sodium alkoxide, whatever. Now we can come here. And then what about if I add to a phenol? This is important because we want to know the things that react with phenol. The things that react with this phenol like this. Okay? So here we have it. If I add a metal, it reacts with phenol. So metals react with phenol. We put the very same way which we just saw. And you'll be having like this, like this. This becomes O minus Na plus hydrogen, H2, because this H, 2 of them will go. Okay? Right, that's what happens. And you have 2 of this, and now this is called sodium phenoxide, okay, because it was from a phenol. Whatever. Now you can come and do again with your phenol. You can have your phenol, but you cannot add metal hydride, but you add instead a metal hydroxide. Okay, so you can add NaOH. You don't have to put 2 of them. You can add NaOH. And then what happens now? Again, this goes and Na goes there, so it's just going to be like this. So it's like this, it becomes O minus Na plus. But then what happens? The H comes and joins the OH and it becomes H2O. So this is just what happens to your what is it, alcohols. You can see what is happening so far. It's like a summary. I hope you're getting it. It's not too much, is it? I mean, I want to show you the questions in the tutorials and the tests, but I don't want you to ever stop and come back and whatever. It just has to be coming from your head and you'll be remembering. Now, the last thing about alcohols that you must remember is the combustion of alcohols. Remember, combustion and oxidation are different. Oxidation, you use an oxidizing agent. Combustion, you react with oxygen itself, not an oxidizing agent like KMnO4. No. You react with oxygen itself. So you may have an alcohol, CH3OH, you react with oxygen itself, okay? What are you going to get? You just get carbon dioxide. So you just get carbon dioxide and you get water and you get some energy, of course, because when you combust, you heat. It's burning. So it's and water and energy. So whatever. So this you can try to balance it. They balance it by putting 2 and 3 and 2 here. But even if you don't balance, you get part marks. Okay, it just makes carbon dioxide, water, and energy. That's combustion of an alcohol, right? Then the last thing to know is what we call the breathalyzer test. Breathalyzer test is just oxidation. Okay, it's just oxidation. It's again oxidation, but here they just like to put it as ions, not just as an oxidizing agent. So you use an acid and you use an oxidizing agent, which has chromium, so Cr2O7, but it's a 2 minus. You remember it was K2Cr2O7, but here we are looking at it as the ion, okay, as the chromium ion, which is going to be orange in color. This is an orange thing. So if you come with acidified dichromate, this chromate ion, dichromate ion, if you come and you add it to an alcohol, if there is alcohol present, then it's going to change color. So we can use it to like A breathalyzer test just checks if you have if you're drunk or not. So and we know that if you come with this ion, which is orange, and it meets alcohol, it will change to green. Okay, it changed to a chromium 3 plus, which is green. Which is green. Here we had it as orange. Now it will change to a chromium 3 plus. And what makes it do that is this alcohol is oxidized to a carboxylic acid. This is ethanol, right? Ethanol is the alcohol you find in all these alcohols, these beverages. Okay, it's ethanol. So ethanol will be changed to ethanoic acid. How? We know that we'll be just putting it as C. We can put it as a CH3, then COOH. That is ethanoic acid. Okay, and water is released as a byproduct when you do this, when you oxidize. Remember that. So basically, we have done that, and that is it. You'll be done. This is how you do it. But remember to put in here. This is Cr2. So you have 2 of them. Anyway, this is the end of it. These are all the reactions for alcohols which you gotta know. Breathalyzer test, where you have ethanol converted to ethanoic acid. This is ethanoic acid, okay, and water. So, all right. Now, what else did we have? Combustion. We have combustion with carbon dioxide, water, and energy. Then we had it here. The straight chain alcohols reacted with the metal and the metal hydride. Then here we had phenol reacted with the metal and sodium hydroxide for phenol. Remember that. Then here we have oxidation with our oxidizing agent. We have esterification, not a problem. Then here we had halogenation, where you add a halogen, and we've got these 3 guys that can be added. And we know that this guy will never work for anything which is cyclic, okay? Never, never, never. For cyclic, you use these 2 guys. That's basically the most important thing to remember on that. And you must remember the things they release as byproducts. SOCO2E, it works on cyclic. We like to use it for things that have high melting and boiling points, okay? So if something has a high melting and boiling point, you have to use SOCl2. That is the one which works. And remember to put pyridine. And what are you going to get? SO2 and HCl again. After you just remove the OH and put then remember to put HCl and SO2. Then here we just get H3PO3. Where is it? Here you just get your H3PO3. But remember, you'll be doing 3. You do 3 of the guys, so that you get H3PO3. That's just going to be happen. And it's going to be the end. That's just all you gotta know. And you'd be done. Remember that this HBr is, we are adding it right now to an alcohol, and we are getting a halogen. We can add it again to an alkene. This HBr is added again to an alkene. So when we talk about alkenes, in hydration, we add H2O and acid and an acid, but we can also add this thing, and it will give us a halogenoalkane. So what are the ways of making halogenoalkanes? One is by doing this, what we are doing here, halogenation of alcohols. Then the other one is adding this same HCl or HBr. You can add it to an alkene again. Yes, you can add it to an alkene, and you are still going to get a halogenoalkane. All right? And what about to come from those halogenoalkanes to alcohols? We add NaOH. We talked about it. And here, this is one of the important things to remember. We add NaOH and water. And you're going to see us using these halogenoalkanes again to make amines. They're used to make alcohols, and they're used to make amines. They are very, very important in those things. Okay? Now we want to go to the next thing, which is very linked to alcohols, but we want to do the questions, and we'll see the thing which is very linked to alcohols, which is ethers. It's going to help you just answer all the questions, all right?